All right, we are on the last passage, passage 5 from Test 2. This one is adapted from Jeffrey Giller, and here's what it's called: Long a Mystery. How 500-meter high undersea waves form is revealed. So this looks like it's about undersea waves and how they're formed, so probably a scientific passage. So here we go. So let's go ahead and get started here. Number 43 says the first paragraph mainly serves to what? So we're going to read that first paragraph. What's the purpose of it? Why is it there? Because I say serves mainly to. So let's do that. Passage number 1, or paragraph 1, I mean. Some of the largest ocean waves in the world, so they're talking about ocean waves, largest in the world, are nearly impossible to see. Unlike other large waves, these rollers, called internal waves, do not ride the ocean's surface. So they're just kind of telling you what they do. Instead, they move underwater, undetectable without the use of satellite imagery or sophisticated monitoring equipment. Despite their hidden nature, internal waves are fundamental parts of ocean water dynamics, transferring heat to the ocean depths and bringing up cold water from below, and they can reach staggering heights, some as tall as skyscrapers. So in this first paragraph, looks like they introduce the concept of internal waves, explain what they do in terms of their importance, and just kind of talks about how big they are, I guess. But really, I'd say it's more about this is what an internal wave is, and this is why it's important. So that's the main function of the first paragraph. So we're going to look at our answer choices and see what matches. Does it explain how a scientific device is used? No. Does it note a common misconceptions? No. Does it describe a natural phenomenon, internal waves, and address its importance, the transfer of heat and cold water up and down in the ocean depths? So that's good. Does it present a recent study? No. So C is going to be your answer for 43. 44, as used in line 19, capture is closest in meaning to what? So we're going to see what capture means in line 19 in context. So in this one, it says, if we want, and I'm going to start right here, if we want to have more and more accurate climate models, we have to be able to capture processes such as this. So when I see this, I'm thinking we have to be able to probably record these types of processes and things like that to capture it, to be able to see it. We have to record it. So I'm going to see which one will probably match that based on the models and the context of the sentence. Now again, sometimes you have to read a few sentences before, a few sentences after, but it seems like in context of the sentence, if you can figure it out, then you figured it out. If you're not sure, then keep reading until you can. Here it says control, no. Record is exactly the word I came up with, so I'm probably going to like that one. Secure. Record is a little bit better. Like secure can have different meanings, but I would say if it wasn't for record being there, secure might be kind of close, but it's not. Absorb, no. So record is exactly the word I came up with, that content or context. So we're going to pick B for number 44. 45 says, according to Peacock, the ability to monitor internal waves is significant. So the ability to monitor the waves is significant primarily because. So this is going to be one of those evidence-based questions. Just know what you're looking for. We want to know the significance of monitoring the waves. So they have to be able to say two things. The evidence needs to be talking about monitoring these internal waves, and it has to be talking about its significance. So we're going to look for the answer choice that matches that. I'm going to show you the one that does it. So 17 through 19 says, which we were just reading for the previous question, but if you're looking, it says, if we want to have more and more accurate climate models, so they're talking about modeling them, we have to be able to capture processes such as this. So when you look at this answer choice, again, the question was talking about the ability to monitor is significant. Why? Well, we want to have more accurate climate models. That's the why, and we have to be able to record the processes. So that's going to be monitoring these waves. So this is mentioning both those things, and again, it's because we want to be able to have more accurate climate models, and that's the reason why, and that's what we want to capture from that. So you look at your answer choices. It will allow scientists to verify maximum height. No, it's about climate models. It will allow researchers to shift their focus, improving the quality of satellite images. No. Study of wave patterns will enable regions to predict and prevent coastal damage. No. D says the study of such waves will inform the development of key scientific models. Now notice it doesn't say climate models, but nothing else does either, and this one is at least vague enough where we can push that into the realm of climate models. It may have key developments in other models as well, but one scientific model is a climate model. So this would fit the best based off the answer choices that we have. So remember, you look for the evidence. You want to make sure you know what you're looking for, so when you find it, you know you found it, and then you can check your answers to 45. So that's 45 and 46. 47, as used in line 65, devise most nearly means. So again, we're going to go to line 65 and maybe read a few lines before or after. It depends, but we want to see which word closely matches devise. So line 65, researchers were also able to devise a mathematical model that describes the movement and formation of these waves. So they were able to, I would say maybe like make, like, you know, so you're thinking of something that's close to making a model that describes, so they made this thing. So again, if you read as far as you need to, that's all I need to read. I'm thinking something like make, create would work that. Solve, you know, they said mathematical, just because it says math doesn't mean you solve. They made a model, so no. C, imagine, no. D, begin, no. It's going to be create, which is making something. So that's going to be 47. 48 says, based on the information in the passage, it can reasonably be inferred that all eternal waves. So it's an inference, so they may not say it directly, but something that would help us relate some information that's true for all internal waves. So that's what we're going to be looking for on 48 or 49. We're looking at the evidence. So when you're looking at these lines, again for 49, the one that's going to relate, again, we're looking for something that relates to, again, all internal waves, and it's going to be inferred, so it's not going to say it directly, but you can get the idea. So anyway, the answer here that I would be looking for, just to kind of, again, save us time and show you what that answer would look like, it's going to be 67 through 70. And here's where that comes. Whereas the model is specific to the Luzon Strait, it can still help researchers understand how internal waves are generated in other places around the world. Right here's the big one. Around the world, it's kind of be like all waves all throughout the world. And again, it has to be inferred, so it's not going to say directly, but that's about as close as you're going to get. So that's going to be your evidence. So all internal waves, there we go. All right, so again, question 48 says it can be inferred that all internal waves, in this case, you know, we're taking a model and using that to help understand how they act in other places. So we want to see an answer choice that would kind of fit that. So by the way, our answer for 49 was going to be, was that D? So D is our answer for 49. And now as we do that, now we look at our other answer choices for 48 and see which one matches. So all internal waves reach approximately the same height. There's nothing here about height. Through the locations and depths of continental shelves vary. Now they were probably going to mention this a little bit, but they're not saying same height, so it doesn't matter. All internal waves may be caused by similar factors, but are influenced by, so they could be similar, so they're using the information from this one, from the one strait, but are influenced by distinct topographies of different regions. So they're using these factors, these similar factors, to predict how they would react in different places around the world. That seems to kind of match those things. The other places around the world would be distinct topographies of different regions. So B sounds good, actually. C, internal waves can be traced to inconsistencies in the tidal patterns of deep ocean water located near islands. That's way too specific. D says all internal waves are generated by the movement of dense water over a relatively flat section. Again, this is way too specific because you're trying to refer to other places in the world. So B is going to be your best answer. It kind of matches both components. So that's going to be 48 and 49. And then we get into the graphs. 50 says, in the graph, which isotherm displays an increase in depth below the surface during the period 1912 to 20 to 24. So they're giving us something to look at here during this period. So that's going to give us a little bit of help here. So which isotherm displays an increase in depth below during this period? So we're going to look at the graph. And we're going to look at the period between 1912, 2024. So that's going to be 1912 to 2024. So there we go. All right. So if you look, our answer choices are basically those four temperatures. So we want to say which displays an increase in depth. So the key on this is when you see the word increase, you think up. What's going up? Which would be confusing because we have 1, 2, 3 things going up, but it's an increase in depth, so it's actually the one that's going down. So we're actually looking at this one right here because it's going down, not up, and that's going to be the 13 degrees Celsius one. So we are going to pick 13 degrees Celsius. That's going to be number 50. So that's kind of tricky when they say that increase, but increase in depth. Make sure you understand the whole full context of what that means. So that moves us on to 51. And this one says which concept is supported by the passage and by the information in the graph. Now, to help make this one a little easier, I'm going to focus on the information in the graph because we can see the graph really quick. The passage, we have to remember things. We have to be able to kind of maybe potentially even go back into the passage and find specific information. It's so much easier just to look at the graph. So whatever answer we pick has to be true in the graph. So let's just focus on that and see if we have to go back to the passage at all. So this one we have to see what they're saying so we can match it with the graph and see if it's true. So A says internal waves cause water of varying salinity to mix. Now this graph doesn't really talk about salinity at all. So because of that, there's no way that this is going to mention it. And I don't remember them talking about salinity in the passage either. So we're just going to go ahead and get rid of A. It doesn't sound like a good answer at all. Next, B says internal waves push denser water above layers of less dense water. And again, there's nothing here in the graph about density. So because of that, we can't say that it's true in the graph. Remember, we're focusing on the graph right now. If the graph doesn't say it, I don't care if the passage talks about it or not. C says internal waves push bands of cold water above bands of warmer water. So we are talking about temperature. So this is saying that, again, cold water above warmer water. So we're going to look for cold water to be above warmer water. And here's my cold water here. All these ones you see, there's no point where my colder water, because it gets colder as you kind of go up, they don't cross over each other. So I'm not going to pick that because it's not showing it. It's not showing that they're pushing it above it. So I'm not going to say that. So C isn't it. But again, maybe you can be like, it's like at least they're talking about the temperature. So like I would keep C. Maybe there's something I was missing, But let's go to D. Internal waves do not rise to break the ocean's surface. Now, when you look here, we do have depth. Our depth is 0. Notice those waves never get above 0 for depth. It's always below the ocean's surface, which means that looks like an answer to me because the graph supports it. And obviously it's in the passage. I say that right at the beginning of the passage, like literally the first lines. They talk about what internal waves are, and they describe that they do not ride the ocean surface right here. So, I mean, it says in the passage, but notice you didn't even have to know that. You would get it anyway. So that's going to be 51. So now last one, 52. This one says, how does the graph support? So again, we're focusing on this graph and how it supports the author's point that internal waves affect ocean water dynamics. Now, it's nice if you can pull, if you know exactly where to go and pull information from the passage. What I would tend to do, however, again, look at these answer choices, see what it's saying, and see if the graph matches it. Again, it's telling the graph has to support it, so the graph has to be true to the statement. And then hopefully from there you can realize, like, yeah, that was actually mentioned in the passage as well. So let's look at the answer choices, go in and check the graph. So A says it demonstrates that wave movement forces warmer water down to depths that are typically colder. So here they're kind of have some scenarios here where we have warmer water, which, you know, notice they don't ever overlap, but like certain sections like we have right here, notice that's normally at this point, if you kind of go across here, normally that's colder water. Okay, so that is an example of maybe where it does do that. So I would keep that as an option. I mean, it looks like there's only one big time that happens there, but then you can look at other points like right here where that gets pushed down as well. So there's a couple times you can kind of see that happening. And if you remember from the beginning of the passage, they did talk about how colder, warmer water, the internal waves kind of move warmer water down and colder water up. So I do mention that, remember that being mentioned at the very beginning, the first few lines of the passage. B says it reveals the degree to which an internal wave affects the density. The graph isn't talking about density, so I'm going to get rid of B. It illustrates C. It illustrates the change in surface temperature. That doesn't say anything about that. So C doesn't even go to the surface, so we're not going to pick that. D says it shows that multiple waves rising near the surface of the ocean disrupt the flow of normal tides. That's not mentioned at all either. In the graph, there's nothing about tides and nothing reaches the surface anyway. So A is going to be your best answer. It's in the graph, and the first few lines of the passage also mention it. So that is Test 2, Section 1.